Hi everyone, this is our demo video for group6-lab9. First we need to install the Termux and Termux API. So first we create the SSH connection to our Android phone. And we can use command line like Termux sensor to check all the available sensors in the Android phone. Here is a light sensor, here is a proximity sensor and the accelerometers we can use in this form, and we can use this command line to check all the value of these sensors. Oops. Okay, now it works. Here's the value of the screen orientation sensor and the 3 values of the accelerometer and the light sensor. And that's it. And next we need to set up the AWS IoT. So first we need to create a scene, and here we name it as Android phone, and download the certificates for later use, and that's it for this part. Later on we need to run the red node on our PC. Now it's running, and then we can check the flow chart. This one is from the instruction, the original one. First, we listen the data from the phone, and then we JSONify the data and process the data. Finally, we post the data to our AWS, to our IoT. We can see the keywords is my topic, and we need to update the certificates we just downloaded from the AWS IoT. It includes the private key, CA, and the certificate. And we also need to make add a request to post our things to the EC2, which we will run the things board. And that's the original structure of the Node-RED. But later on we made a modification to this flow chart, but we will talk about this later. And the next step we need to post the data from the Android phone to PC. There's 2 methods. The first way is to install a Node-RED and Termux module on our Android phone. So it should be like this. First, we need to create a timestamp and get the value of the sensor, and then post the data to our personal computer. But we will later on modify the original flowchart to like this. We collect the 4 sensors data and make 2 HTTP requests of each sensor value, so both of the 2 of our teammates can get the value. Let's check it on our AWS. My topic. My topic. Oh well. deploy it again. Oh, now it works. The proximity and accelerometer. We can see the values in our IoT instance. So next step, okay, so there's a second method called curl HTTP post that we will just collect the data and use HTTP post post the data from the iPhone to the PC using just a script. We can also check this by run. Okay, so finally it works. Let's do this again. First we need to kill the original scripts. And then we'll run the script again. So we just read the data from the sensor and post the data to our Node-RED. This is the value of the accelerometer, and we will receive the data from the Node-RED on our personal computer. So we'll just stop it. Stop the script. And that's it. Okay, let's continue. Then we need to virtualize the data in our IoT, which is the EC2 instance created above. Let's disable and deploy it again. So we'll make the request to post the data to our IoT instance that we created here. The name is Android phone. The version is 20.04 of the Ubuntu. Okay. So let's run the Node-RED on both our phone and computer. And the Node-RED here. Therefore we can SSH into our EC2, which is this one, and start the sync board. So it works. Okay. So we have four devices. The first one is proximity sensor and orientation sensor, accelerometer, and light sensor. We can check the value. It changes all the time. This is what it just received. This one. Because we post each value. This flowchart is posting the accelerometer data using this HTTP request, and here's the token. And second one is the orientation sensor. Third one is the light sensor, and the last one is the proximity sensor. Therefore, we we received all the data we need, and then we can create a dashboard. Here we already created it, and we can see the light sensor, the data we just received, and it's dynamically updating. Virtualize the data in AWS and on ThinkBoard. And that's it for my part.
In the step 8, we create the keys file host stream to read the data from IoT core, then write the data into S3 bucket every 120 seconds. Here is the detailed step. Firstly, we create the file host and we set the destination to S3 bucket we created before, and the name of the ARN of the S3 bucket is this one. And we set the rules configuration, add the rules. Here's the socket bucket, the destination bucket, and the rules is if the data arrived 5 megabytes, we will write, or we set the interval to 60 seconds because it's more convenient for us to debug. So instead of 120 seconds, we set it to 60 seconds. And also we need to give it a role. Let's take a look at the role. We should assign the some permission to it, like the full access to S3 bucket, because it need to write into S3 bucket. So let's look into the S3 bucket. In the S3 bucket, the data will be written into this folder. It's 2023 October and 21st. And here are the data. Just click download it and let's check it out. So here is the data. As you can see, the timestamp here is timestamp, and the value in the value we got the date. Here is the human readable date and the value proximity. Proximity is one of the sensor. And also let's take a look at the second entry. The timestamps here, the values here is accelerate monitor. It has 3 value, 1, 2, 3, and here's the date. Also, we have the screen orientation, and we have light sensor because our phone only has 4 sensors, so we can get the value of these 4 sensor. Yes. So by doing this, we can read the data from the IoT to the file host and read the data, write the data in from file host into the S3 bucket every 120 seconds. First task. First, let's look at the first problem. At the stem tab. For this question, we write a lambda function, and we set the trigger to S3 bucket. And every time the S3 bucket trigger the lambda function, the lambda function will format the data into this one. Let's take a look at it. Let's find the lambda function. And here is the code. Let's take a look at it. From the event we get the payload, and we use form value, use this helper function. So you create a empty array and append the date time into the array, and append the sensor value into the array. Therefore, we formatted that data and write that data into corresponding files. Then we read the existing data and combine the existing data and the new formatted data and write the new file into S3 bucket. So let's check the S3 bucket. 5 sensors. We have 4 sensors, so we have 4 file. each file stores the corresponding sensor's value. Let's check out the AZC.txt. As you can see, we format the value here. It's the human readable date, and there are 3 values in the AZC accelerate monitor. There are a lot of data. Then let's check another one. And also you can see the last modified data is here. And here is the light sensor, the human readable date, and the value is here. Okay. Let's take a look at the second question. You should take for at least 5 sensors and add it into timestamp. I already get the firstly let's check out the here. Because we only have 4 sensors, so we use these 4 sensors, read the sensors, and use HTTP request to put the sensor from our Android phone to our desktop. As you can see, let's check out one of it. Here is the private IP address, and here is the endpoint. And in our desktop, we also create 4 HTTP request and a listener. We use the listener to listen the HTTP request from our Android phone, and we get the data. As you can see, let's check out this one. Get the data. This one is the accelerator value, so it got 3 value. So we just format the data, give it a human readable date, and give it a timestamp, and we just combine those data into a dictionary timestamp value, and there are 3 values in the accelerate monitor, and we use PS to represent timestamp, because in the SynSport, it asks if we want to use our own timestamp instead of the SynSport system timestamp. We need to upload our data like this format, and values like this. So by doing this, we can upload the data from our PC desktop to the EC2 and EC2 SynSport. Let's take a look at the SynSport. So I already created a SynSport EC2 named SynSport, but it is crashed because it's the T2 micro. So I have to reboot it. So let's let the EC2 reboot and go to the next 3 problem and wait it finish booting. Then we will go back to the SynSport. So let's take a look at the problem 3. Write a lambda function to write to DynamoDB. So take a look at let's take a look at here lambda function DynamoDB. So firstly, we should create a DynamoDB. We created a DynamoDB, and here is the table. And let's check out the table details. We use date as the partition key and no sort key, and that's it. Here, and the name of the DynamoDB is group6-lab9. So we write this dynamo function. No, is it? Yes. So create a empty data dictionary, and we use the data date to feed the partition key, and we add the ID and add the timestamp and add the sensor's value according to the type of the sensor. Maybe it's the accelerate or proximity or light sensor or screen orientation. And then after this, we just put the new item into the table here. So we already deployed this lambda function. Of course, we should give the permission to DynamoDB to this lambda function, and also give the permission to S3 bucket to read the data and write into the DynamoDB. So let's check out the DynamoDB. So explore items. So we got these items. The date is the partition key, and as you can see, this one and all of them got a unique ID and the sensor's value. And next problem 4, write a lambda function every 240 seconds. So let's take a look at the lambda function that is Is it batching? Yes, batching. So because the file house will write into the S3 every 120 seconds. So we should at the 120 second, we just need to remember the file house just read into the S3 bucket. Then at the 240 seconds, we get a new file. We just need to get that two new file and write them into the get that new file and read the data from that two new file and write that data into the file that all data will be saved in one single file. Because we have 4 different sensors, so we got 4 different files. Each of them store one different type of the sensor. So let's take a look at the first. We should get the listen the event. The trigger is S3 bucket. Once the S3 bucket was written by the file house, it will trigger this function. So we got the bucket when it is triggered. We will get the bucket and we'll get the key, and we generate a new file named this one, and we will check if this new file exists. If it not exists, we will create this new file, and we just write the key to it, which is the path and the name of the new data file, and we just return. And once the lambda function is triggered again, we will enter this lambda handler again. We got this new file, we got the key, and we will check whether this file exists. So this time, this file will exist. So we will read the key from this file, and we will get the file name written at the 120 seconds. Also, we will get the file name written at the 240 seconds. So we got the name of these two new data file. So we will just download this two new file and read the data from the two file, and we just read the data and format the data and write the data into 4 different files, which stores the 4 different types of the sensor. So let's check out the bucket. As you can see here, 1, 2, 3, 4. These 4 files will be written every 240 seconds to store the different type of the sensor data. For example, let's check out the ACC JSON download. As you can see here. And let's check out the proximity. As you can see, here's the data. And here also, of course, there will be a new file, the txt, which stored the file name written at 120 seconds. So by doing this, we can create 4 different files, stores all data up to that point. And take a look at the step 5. Every 240 seconds, find the median, mean, standard deviation. Also, by doing this, we create a lambda function, and the trigger is also the S3 bucket. So let's take a look at the lambda function. Of course, we should assign the permission to this lambda function to let them access DynamoDB or access IoT or access S3 bucket. So let's take a look at this function. The trigger is the S3 bucket, and the trigger is the put of light sensor. We only give the statistics for this sensor, light sensor. So the trigger is this file. Once this file is put, so we will process the data to calculate the median, the mean, and the standard deviation. So here also, because we need to keep a track to the time, 240 seconds or 480 seconds, we have to keep track of that time. We need to create a data in the DynamoDB to keep track of the time. Also, you can find here, if run the DynamoDB, you can find here the count here. So once the light sensor JSON, once this file is written, we will trigger this number function to fetch data from S3 bucket and extract the light sensor values and calculate the mean, calculate the median, and calculate the standard deviation. And we will group the data according to the defined standard deviation, like median plus one standard deviation, median subtract one standard deviation, like this. Then we will format the data, or we will append the data to the groups. Then we format the data. We create a result. We create a string named result data and store timestamp, median, and the mean and standard deviation. Also store the groups. Then we create a new file. This is the file name, and we try to find this file. If the file already exists, we just append the statistics to the file. If the file is not exist, we create that file and put the statistics into that file, and we just write the data into it. So let's check the here the statistics. So you can see, because I delete the timestamp 240 seconds by mistake. So here is the remaining at time stamp equal to 480, median equal to 29. The mean is here, standard deviation is here, median plus 1, and standard deviation equal to empty and here. And here, these are the statistics we written into this statistics file. As you can see now, at timestamp equal to 3120 seconds, the median equal to 12 and the mean equal to 15. And we got the groups like here. So we finished the step 5, and let's go back to the step 2. So hope it has already finished the booting. And since for do those surveys. Okay, we start the scenes board and let's log in. I forgot it. Let's check out the 69996. Here is the account and the password. Let's log in using the account and the password. And the connection is not good, so it takes a little bit of time to log in. Let's check the devices I created before: screen orientation, light, proximity, and extra accelerate. And checked telemetry. As you can see, here's the daytime, and there are 3 values. And here, and let's go to the dashboard. Let's check out what we created for lab 9. Okay, let's look at the slides, because the scenes board on the EC2 cannot be logged into because the performance of the EC2 is not good. So I tried several times and really cannot connect the EC2 and log into the scenes board. But we got the screenshot for the dashboard of the scenes board before. So let's take a look at. We firstly create 4 devices to get the HTTP request from our host PC. So we get data, and we create the device to receive that data. Then we just create of course, the data, the type of data is consists of text and value. In this way, we can use our own timestamp. And after receiving the data by creating the devices. We just create the widget in the dashboard. So we create 4 widgets as you can see here, screen orientation, light, proximity, and accelerate sensor. And these 4 widgets can show the data according to the our own timestamp. Yes, this is step 2. So this is all the work we finished in the lab 9. Thank you very much.